Here's the answer for day 2, problem 1. Given function f and function g, find the following combinations of functions. For question A, we're supposed to subtract functions f and g. So begin with function f, which is negative x plus 3, and subtract function g. Function g is 2x minus 4. Be careful to put the 2x minus 4 in parentheses so as to properly subtract each of those terms. Negative x subtract 2x is negative 3x, and a 3 subtract a negative 4 is equal to positive 7. So negative 3x plus 7 is the answer. Question B, f times g times x. So we'll take function f, which is negative x plus 3, multiply it to function g, which is 2x minus 4. Let's use FOIL to multiply these binomials. Negative x times 2x is negative 2x squared. Negative x times negative 4 is positive 4x. Now the inner product, 3 times 2x is 6x. And 3 times negative 4 is a negative 12. We'll combine the middle two terms together to get the final answer. Negative 2x squared plus 10x minus 12. Question C, let's do the composition of function f and g. So we want to find f of g of x, where we're going to input the function rule for g of x into the variable for f. If you look back up here at the functions, take the function rule for g of x and input it into the variable for function f. That would create negative, and then in parentheses we'll substitute in the 2x minus 4. And then the rest of function f is a plus 3. Now simplify. Negative 2x, negative of negative 4 makes positive 4, and then add 3 is positive 7. So the final answer is negative 2x plus 7. Day 2, problem 2. Solve the quadratic equation by completing the square. That means we want this trinomial to be a perfect square trinomial, and it's not right now. I know that it's not because when I look at the middle term and take half of the middle term, that's negative 3, squaring negative 3 is positive 9. This number here has to be positive 9 for this to be a perfect square trinomial, and it's not. So let's cause it to be positive 9. First step is to add the 4 to the right side of the equation and leave a blank spot here in which we could insert a positive 9. So put in plus 9, and then on the right side, plus 9. This is now a perfect square trinomial, and it factors into a binomial squared pattern. The square root of x squared is x, the square root of 9 is 3, and because the middle term is negative, we want that to be a negative. On the right-hand side of the equals, it makes 13. Now let's do a square root in order to remove the exponent. So on the left side, we get x minus 3, and on the right side, the plus or minus square root of 13. Final step, add the 3 to both sides of the equation to isolate x. X equals 3 plus or minus the square root of 13. Completing the square is one technique to solve quadratic equations.